Hello students, in this video we are solving JEE Mains 2026 2nd April Shift 1 Maths questions from 6 to 10. In previous video we discussed from 1 to 5. Now let us look at this first question, sixth question actually. The number of 7-digit numbers that can be formed by using the digits 1, 2, 3, 5 and 7 such that each digit is used at least once. Okay, so if every digit is used at least once, there are 5 digits actually. So you will definitely have 5 digits, and the remaining 2 digits can be anything from these 5 digits. If you add a rule that there should be any repetition, then what will happen? You will select only two out of these five. So you will get five selections into. Then if you are not repeating any digit here, then you are definitely repeating 2 digits. If you are having one here, you will get one here, or two here, then two here. And similarly, you will get these 2 digits will be present here. So what will happen is you will get total 7 factorial by 2 factorial into 2 factorial arrangements if you use a condition without repetition. If you use with repetition condition, then you will select only one out of these 5 digits here, and that digit will repeat three times in all these 7-digit numbers. So first you can select five. You will get 5 selections out of these 5 digits. So 5 into, and there are 7 digits, so you can arrange them in 7 factorial ways. Since there are 3 digits which are repeating, so you will divide it with 3 factorial. So these are the total number of arrangements or 7-digit numbers that you will get from these 5 digits. What is 7 factorial by 2 factorial into 2 factorial? So 7 into 6 into 5 into 4 to 3 into 2, 5, 4 into 5 factorial by 3 factorial into 2 factorial. So 3 into 2, 3 factorial gets cancelled, 4, 4 gets cancelled, 2 and 2 threes plus here 5 into 7, 6, 5 and 4. Let us multiply these numbers. You will get 5 factorial is 120, 120 into 21 into 5. 21 into 5 is 105 into 120. You will get 12 5 60, 12 ones 12, 12,600 plus this 5 fours 20, 6 sevens 42, so 840 into 5, 5 fours 20, 5 is 40, 4200 here. So in total you will get 16800, 7-digit numbers uh, which satisfy the given condition. So answer is option C. Let us move on to next question. Okay, now look at this question. The number of elements in the set S, which is order pair R comma K belongs to integers, and R should satisfy this equation. R and K both should satisfy this equation. So let us solve the equation. 36C R plus 1 is nothing but 36 factorial by 36 minus R minus 1. So 35 minus R factorial into R plus 1 factorial is equal to 6 into 35CR by K square minus 3. So 6 by K square minus 3 into 35 factorial by 35 minus R factorial into R factorial. So 35 factorial and factorial here gets cancelled. 35 minus R factorial gets cancelled. R factorial and the here factorial gets cancelled. You are left with, oh, once again, here 6 ones, 6, 6. So if you do the cross multiplication, you will get 6 of k square minus 3 equal to r plus 1. So that is equal to 6k square minus 18 equal to r plus 1. So r is equals to 6k square minus 19. And we know the condition for r. R should be less than 35, less than or equal to 35. So 6k square minus 19 should be less than or equal to 35. And it should be greater than or equal to 0. We know that. So 6k square should be greater than or equal to 19 and less than or equal to 40, 54. So 19 by 6 k square and then 9. From this, we'll get two conditions. The first thing is k square should be less than or equal to 9 and k square should be greater than or equal to 19 by 6. That means the two critical points for first equation is 3 and minus 3. It should be less than 9. So the required region is between minus 3 and 3. And coming to k should be, k, you will get two values here, which is root 19 by 6 and minus root 19 by 6. Since it should be greater, k square should be greater than this. So we'll take all the values right side of this root 16, root 19 by 6 and all the values which are left side of minus root 19 by 16. So a common region is minus 3 to minus root 19 by 6 and root 19 by 6 to 3. So k belongs to minus 3 to minus root 19 by 6 union root 19 by 6 to 3. And there is a condition for k should be an integer. So uh, from this we can say that this is less than 2 and similar to 1 point something. So k will be equal to minus 3, minus 2, and it can take it. Can it take minus 1? No, it cannot take minus 1, and it cannot take 1. So from here, it can take 2 and 3. So k can take 4 values. So option B. Let us move on to next question. So here, if the mean of data is 21, then k is one of the roots of these equations. So first let us find the value of k, then we'll find roots of these equations, then we'll select the correct option. So first, how to find mean of this data? Let us write the values of xi, fi. Xi is class mark of this class. So 5 to 10, the class mark would be 7.5 and 12.5, 17.5, 22.5, 27.5, and 32.5. The frequencies are 2, k, 28, 54, k plus 1, and 5. Coming to deviations, let us assume this as our assumed mean. So this becomes minus 10, minus 5, 0, 5, 10, and 50. If you want UI, you will get minus 2, minus 1, 0, 1, 2, and 3. Mean is nothing but a plus summation UI fi by summation fi into h. So our a is 17.5 plus summation UI fi is, oh, let us find fi ui, which is equal to minus 4, minus k 0, 54, 2k plus 2 and 50. So summation of fi ui will become 50 plus 15, 65, 65 plus 2, 67 plus k by sum of frequencies is 28, 30, 35, 40, 90. 90 plus 2k is the sum of frequency. 90 plus into h, class size is 5. So that's it. This should be equal to 21. Let us solve this to get the value of k. If we send this 17.5 to the other side, we'll get 3.5. So 35 by 10 is equal to 67 plus k by 90 plus 2k into 5. So 5 ones, 5 sevens. If we cross multiply, we'll get 63, 7 and 63 plus 15k is equals to 670 plus 10k. So 4k is equals to 40 and k is equals to 10. So k is 10 and one of these equations should satisfy 10. So let us try for the first equation, option A. If we substitute 10 here, we'll get 200 minus 230 minus 10, which will not satisfy equation 1. And option B, 400 minus 350 plus 25. So this also will not satisfy. So let's check for C. 200 minus 190 minus 10. Yes, 100 k is equals to 10 is satisfying option C. So I think the answer is C. Let us check for D also. So it becomes 200 minus 350 plus 98. So our answer is option C. Let us move to question number 9. So in question number 9, what he's saying is, let the midpoint of sides of the triangle ABC be these values. If its in center is h comma k, then find the value of 3h plus k. So let us draw a triangle where this is A, B, and C. And let us assume the midpoints of ABC is DEF, where D is 5 by 2 comma 7, E is 5 by 2 comma 3, and F is 4 comma 5. Now there is a condition to find, there is a formula to get A, B, and C. How to get A? A is equals to E plus F minus D, and for B, what we'll do is F plus D minus E, and C is equals to D plus E minus F. So A is equals to E plus F. So E is 5 by 2 and F is 4. So 5 by 2 plus 4 minus 5 by 2 will give you 4, comma. Coming to y coordinate, 3 plus 5, 8 minus 7 is 1. So you will get 4 comma 1. Similarly for B, F plus D minus E. 4 plus 5 by 2 minus 5 by 2 will give you 4, and F plus D. 5 plus 7, 12 minus 3 is 9. 4 comma 9. And C is equals to D plus E minus F. So 5 by 2 plus 5 by 2 is 5, minus 4 is 1, comma 7 plus 3, 10 minus 5 is 5. So A, B, C are, we got A, B, C through formula. Now, what is the formula to get in center of triangle? In center of triangle is equals to AX1 plus BX2 plus CX3 by A plus B plus C, comma A y1 plus by2 plus cy3 by A plus B plus C. Now what are A, B, and C? A is the distance from BC, so which is equal to under root 4 minus 1, 3 square plus 9 minus 5, 4 square, which will give you 5. And B is equals to AC. That is equal to 4 minus 1, 3 square plus 1 minus 5 minus 4 whole square, which is also 4 square. We will get 5. And C is equals to AC, sorry, AB, which is equal to 4 minus 4, 0 square plus 8 square. C is equals to 8. Now, if we substitute these values in here, we will get I. I is equals to pi of x1 plus pi of x2 plus 8 of x3 by 18 and phi of y1, phi of y2, 8 of y3 by 8. What are the values of x1, y1? x1 is 4, x2 is also 4, x3 is 5, y1 is 1, y2 is 9, and y3 is 5. Let us solve this. So we'll get 20, 20, 48, 48 by 18. So what is 48 by 18? 6, 3, 6, 8. So 8 by 3, comma. This is 5 and this is 45, 50. 50 plus 40 is 90, 90 by 18 is 5. So these are h comma k. We have to find 3h plus k. So if this is h and this is k, 3h plus k is equals to 3 into 8 by 3 plus 5, which is equal to 13. So the answer is 13, option C. Now let us look at the last question. So here, let an ellipse x square by a square plus y square by b square is equals to 1 passes through 4 comma 3 and has eccentricity of root 5 by 3. Then the lattice rectum of, okay, you have to find the length of lattice rectum of this ellipse. Since A is less than B, the ellipse has y-axis as its major axis. Let me draw the diagram. This is how the ellipse may be. This is B and this is A. Now, we know the formula to find eccentricity of ellipse, that is equal to under root 1 minus a square by b square if b is the major axis. So it is given as p is equals to root 5 by 3 and that is equal to root 1 minus a square by b square. If you send the root to other side, you will get 5 by 9 equal to 1 minus a square by b square. So if you transpose to the other side, you will get a square by b square equal to 4 by 9. Now from this, we will get a relation between b square and a square. B square equals to 9 by 4 a square. Since the given ellipse is passing through 4 comma 3, let us substitute the values. 4 square by a square plus 3 square by b square. What is the value of b? 9 by 4 a square. So 9a square into 4. Here 3 square and 9 gets cancelled and you can take a square common and send it to other side. 4 square is 16 and 16 plus 4 is 20. 20 equals to a square. So a is equals to root 20, which is equal to 2 root 5. Now, what is the length of lattice rectum? The length of lattice rectum is equal to 2 a square by b. Since b is the y-axis is our major axis, so 2 into a square is 20 by b. What is the value of b under root? 9 by 4 a square, and that is equal to 3 by 2 into a, which is 2 root 5. So we'll get 3 root 5. So 3 root 5. And if we cancel this, we'll get 20 can be written as 4 into 5 by 3 root 5. So we will get 8 root 5 by 3. So this is the length of lattice rectum of given ellipse. So the answer is option D. Now, so that's it for questions 6 to 10. In next video, we will solve question 11 to 20, 11 to 15 from the same paper. So make sure to subscribe and stay tuned.